Hello everyone and Assalamu alaikum. In this video, I'll be solving difficult questions from some recent GCSE math past papers. I hope you'll find this video helpful for your math exam tomorrow. You'll also find a lot of other helpful content on my YouTube channel. And if you're interested in one-to-one classes, you can find my Instagram and WhatsApp details in the description below as well for your next exams. Now let's start with this. I'm going to start with November 2022 and go backwards from here and do a number of difficult questions from these papers. Now I'm starting with November 2022, question 5 of this. It says, written as the product of prime factors, you have these two numbers, 12,600 and 14,112. We need to work out the HCF, the highest common factor of these numbers. Now, how do you do that? When you have the prime factorization given, all you need to do is look at the lower powers of these factors that are common. So look at the common factors, common prime factors. So 2 is a common prime factor. Take the lower power, take the smaller power. So you have 3 here, that's the smaller power out of 3 and 5. And then for 3, the smaller power, well, both of them are equal. So you can take any of them. You can take 2 from here or from here. The next number is 5. Well, we don't have 5 as a factor of 14,112. You can think of it like this: 5 raised to power 0, which is 1. So we don't take 5 here at all because that's not common between the two numbers. And then for 7, the smaller power is 1. So that's what we take from here. So what is going to be the HCF now? We say the HCF is 2 raised to power 3 into 3 raised to power 2 into 7 raised to power 1. You put that in your calculator and you see what that gives you. 2 raised to power 3 into 3 raised to power 2 into 7, and that is giving me 504. That's the HCF. Okay, so for HCF, you take the smaller of the two powers that you have for a common factor that you have in the numbers. Okay, now let's move on to the next one. This is question number 6 from the same paper. The composite bar chart shows information about the percentage of drinks sold by a cafe in 2007 and 2019. It says in 2007, the cafe sold a total of 24,000 drinks. How many more teas than coffees were sold? Okay, now let's have a look at this graph. What does this show? You can see you have information about the sales in 2007 and 2009 for tea and coffee and any other drinks that they have. You have percentages given here. And what they're asking for is in 2007, so we're focusing on 2007 right now, how many more teas than coffees were sold given that the total number of drinks was 24,000? Now you can look at the percentage. Coffee is represented in gray color here. So this is coffee. You can see what percentage you have here. The percentage here is 42. So 42% in 2007 was the number of was the percentage of coffee sold. And then if you look at teas, it's going from 42% all the way up to 90%. So what does that become? So if coffee is 42%, what about tea? That's represented by white color here. T is 90% minus 42%, and that becomes 48%. Now, what's the difference between these two percentages? 48 minus 42, that is 6%. 6%, since we're looking for difference, right? How many more teas were sold as compared to coffees? The difference in percentage is 6%. What's the number of teas that were more than the number of coffees? You can find 6% of 24,000 and see what that gives you. 6 over 100, that's 6% of 24,000, and that's going to give you the number of teas that were greater as compared to the number of coffees. Let's see what that turns out to be. 6 over 100 multiplied by 24,000, and that's giving me 1,440. Okay, this is one way of looking at it. You could look at it another way as well. You can find the number of coffees first by taking 42% of 24,000. You can find the number of teas by taking 48% of 24,000. And then you could have found the difference between those two values, and that would also work. All right, let's move on. Now, question number 6, part B, it says, were more coffees sold at the cafe in 2019 than in 2007? Now, was the number of coffees more in 2019 as compared to 2017? You can see in 2007, the percentage was 42% for coffees, and in 2019, the percentage was 50%. In 2007, the total number of drinks was 24,000. However, the problem is we do not know what the total number in 2019 was. So if in 2019, for instance, the total sales were 50,000, this percentage would obviously be bigger. But if in 2019, the number of drinks sold in total was much lower, if that was 5,000, 50% of 5,000 would be lower than the number of coffees sold in 2007. So since we do not know what the total number in 2019 is, we can't really say anything about the number of coffees sold uh, in 2019, because we do not know the total number of drinks sold. So there's nothing really that we can say about this comparison, because even though we do know the number, we can find the number of coffees sold for 2007, we can't find the number of coffees sold for 2019, since we do not know the total number of coffees sold. So we can't say for sure. We can't say for sure whether the number of coffees in 2007 was more or in 2019 was more. So what do we say then? We say we cannot tell. Okay, just the percentage being bigger does not mean that the actual number is also bigger. Now, what's the reason for this? What reason do we write here? We can say we do not know the total number. We do not know the number of drinks sold in 2019. So there's no way to figure out the number of coffees sold in 2019. All right, question number 7, it says k is a whole number between 40 and 50. The cube root of k is 3 to the nearest whole number. Work out the largest possible value of k. Now, how do we think about this? K is a whole number between 40 and 50, so it could be anywhere between 40 and 50. Whole number means it's an integer. Cube root of k is 3. Okay, cube root of k is 3. To the nearest whole number. Okay, work out the largest possible value of k. Now, let's try to work it out. Let's see what the cube root of 50 is, for instance, right? That could be the largest number between 40 and 50, considering if 50 was to be included, right? If 50 was to be included, let's see what cube root of 50 is. Let me try to work it out on my calculator. Cube root of 50 is 3.68. Okay. 3.68 rounded to the nearest whole number, this would actually be 4. So the value of k cannot be 3, cannot be 50, right? Because cube root of k, when rounded off, it has to be equal to 3. Now, this is not equal to 3, all right? So essentially the idea is we need a number. Since we're looking for the largest possible value of k, we are looking for a number that has its cube root very close to 3.5, right? Because since it's 3 to the nearest whole number, that means the actual value of the cube root could be anywhere between 2.5 and 3.5. Since we want the largest possible value of k, we want to be closer to 3.5 here. Okay. Now, you can try it on your calculator, slightly smaller numbers than 50. You can try 49, for instance. You can try 48 and see what you get. I'm going to do this on my calculator. Or in fact, I can just show this to you in front of you as well. Cube root of 49, let's see what this works at. 3.65, okay, that's not working. Let's try a bigger difference. Let's say 45, okay, this is also 3.55. That's not going to work. 42 maybe. Okay, this is 3. This is going to round off to 3, but is it the largest possible value? We will need to confirm. Let's try 43. Okay, so cube root of 43 is 3.503. This would round up to 4. This is not going to round off to 3, right? Because it's greater than 3.5. However, if we use 42 here, that is slightly less than 50. And that means that this would round off to 3, right? It's slightly less than 3.5. So this is going to round off to 3 now, which means the largest possible value of k that we are looking for here is 42. All right? Because cube root of 42 is what is going to round off to 3. That's the largest possible number that's going to for which the cube root is going to round off to 3. Okay, let's move on. Now we've got a cuboid. W, X, and Y are different whole numbers. Okay, so W, X, and Y are 3 sides of this cuboid, and these are different whole numbers. Okay, they're not all the same. The total length of all the edges of the cuboid is 80 centimeters. Okay, edges means all of these sides, right? These are 4, and then you have these edges here on this side, you have these edges here, and you have these edges here. Okay, so these are basically 12 edges in total. All right, these are 12 edges in total. The total length of all the edges, they're saying that is 80. Now we have 4 sides, 4 edges that have length of W. That means 4W. Similarly, 4 sides, 4 edges that have length X, and then 4 edges that have length Y. So 4W plus 4X plus 4Y, this should equal 80. Now, if we divide this whole equation by 4 to simplify things, we get something like this. W plus X plus Y, that should equal 20. So W, X, and Y are 3 different whole numbers such that their sum is 20. Okay. Now the volume of this cuboid has to be greater than 200. What we need to do is we need to work out one possible set of values for W, X, and Y. Now, how do you find the volume of a cuboid? You say W into X into Y, their product has to be equal to 200. So you need to work out one possible set of values of X, W, X, and Y. Now, you can't find the exact values. There's no unique answer for this. There's no single answer for this. There could be multiple possibilities. You just need to write one possible set of values. So think of 3 numbers, different numbers that add up to 20, and when they multiply, their product is greater than 200. Sorry, it's not equal to 200, it's greater than 200. Let's work out 3 numbers like this. So what possible numbers can we have that add up to 20? Maybe if we use 10, and maybe you can use 4 and 6, right? This could be one possible set of numbers, 10, 4, and 6. Let's see if that works. 10 into 6 into 4, that's a number that is giving us a product of greater than 200. So this is one possible set of values of W, X, and Y. We could say W equals 10, X equals 4, and Y equals 6. There could be other possibilities as well. For example, you could try 9, 6, and 5. Again, you can try that. 9 into 6 into 5. That's also giving me a product of greater than 200. So there could be multiple possible set of values. This is one possible set, 10, 4, and 6, and that is going to be acceptable. All right, let's move on. Question number 10 from this paper. Okay, so let me actually write down these values here. W equals 10, X equals 4, and Y equals 6. Okay, now it says the nth terms of 2 linear sequences, A and B, are added to give the nth term of a new sequence. The new sequence starts like this: 8, 13, 18, and 23. The nth term of a sequence A is n plus 1. Work out the nth term of sequence B. Okay, so we have this sequence, and we have a sequence A, The nth term of the sequence A is n plus 1. There's a sequence B. We do not know what the nth term of that sequence is. And then the total of these two, the sum of these two, because A and B are added to give the nth term of a new sequence, right? Okay, so the nth term of sequence A is n plus 1. The nth term of sequence B is unknown. And the sum of these two sequences, that looks like this. That's 8, 13, 18, 23, and so on. Now, what's the first sequence? A, n plus 1 is the nth term. So what's the first term going to be? 1 plus 1, that's 2. The second term, 2 plus 1, that's 3. The third term is going to be 4, and then 5. Now, one way to look at this is you can find sequence B from this, right? Because if the sum of these first two sequences is giving you this third sequence, what is the second sequence? What is sequence B going to be? 8 minus 2, that's 6. 13 minus 3, that is 10. 18 minus 4, that's 14. 23 minus 5, that is 18. This is the sequence B. And this is the sequence for which we are looking for the nth term. Okay? What's the nth term of the sequence now? It's a linear sequence. We know the nth term formula for a linear sequence. It looks like this: a plus n minus 1 times d. The first term of the sequence is clearly 6. And what's the difference? Difference between the terms is 10 minus 6, and that is 4. Just input those values here and see what that gives you. A is 6, n minus 1 times the difference, which is 4, and that will give you 6 plus 4n minus 4, and the final result turns out to be 4n plus 2. That's the nth term of the sequence B. All right, let's move on. Question number 14 from this paper. It says Fred bought an apartment for £137,500. He made 8% profit when he sold the apartment. He used all of his profit to pay 40% of the deposit on a house. The deposit was 1/6 of the price of the house. Work out the price of the house. Okay, so now how do we think about this? So Fred bought an apartment for this amount. He made 8% profit when he sold the apartment. And then he used all of his profit to pay 40% of the deposit on a house. Now, what's the profit? Let's calculate the profit first of all. What's the profit amount? It's going to be 8% of that. 8 over 100 multiplied by 137,500. You can see what that turns out to be. This is 11,000. So the profit value is 11,000. Now, all of this profit is used to pay 40% of the deposit. So this is 40% of the deposit. Now, let's say that the deposit was D. What that means is 40% of D, we can say 0.04 or 40 over 100 times D, this should equal 11,000, right? 40% of the deposit was 11,000. So 40 over 100 times D equals 11,000. From this, we can find the value of D, the deposit. That's going to be 11,000 into 100 divided by 40. Let's see what that turns out to be. 11,000 into 100 divided by 40, and that is giving me 27,500. That's the value for the deposit that I'm getting. Okay, and now it says this deposit is 1/6 of the price of the house. Let's say the price of the house is P. 1/6 of the price of the house is this deposit. That is 27,500. What's the price of the house then? 27,500 multiplied by 6, and that is giving me 165,000 pounds, and that's the price of the house that we were looking for. Okay, that's question number 14. Let's move on. Question number 24 from this paper. It says B is 60 miles from A on a bearing of 170 degrees. A ship sails from A on a bearing of 247 degrees. it travels at a constant speed of 23 miles per hour for 1.5 hours. Is the ship now closer to B than it was when it left A? You must show your working. Okay, so you can see this on the diagram. This distance from A to B is 60 miles. This angle is 170 degrees. Now the ship sails from A on a bearing of 247 degrees. From A, so from A, it goes at a bearing of 247. Now this is 180. So 247 is going to be somewhere here. So just sketch it like this. We can say the ship is going, okay, I'm sorry about that. The ship is going somewhere here. Okay, such that this complete angle is 247 degrees, right? That's the bearing of this direction, 247. Now, this whole angle is 247. 247 minus 170 is going to give us this angle. Let's see what that turns out to be. 247 minus 170, and that is giving me 77. So that means this angle is 77 degrees, right? Because this total becomes 247 then. Now, if this is 77, we're given that it's traveling at a constant speed of 23 miles per hour for 1.5 hours. What's the distance traveled? Let's find the distance using this. Distance equals speed into time, right? The units are okay here, miles per hour and hours. We'll get a value in miles. So we can say 23 multiplied by 1.5. That's going to be the distance. That is giving me 34.5. So this distance is 34.5. And now what we're looking for is this point, wherever that is. Let's say the ship is here now. Is the ship now closer to B than it was when it left A? Now, is the distance from S to B smaller or the distance from A to B smaller? That is what we want to find out. Now, we already know the distance from A to B is 60 miles. What about the distance from S to B? Can we figure this out somehow? We know this length, we know this length, we know the angle between them, we know the included angle. How do you find this third side, this unknown side? We can use cosine rule for this, right? We know two sides and the angle between them. Let's call this side A. We can say the cosine rule looks like this: A square equals B square plus C square minus 2bc cos of A. Let's call this side A. And then the other two sides are going to be 60 and 34.5 minus 2 into 60 into 34.5 into cos of the angle. The angle is this angle, opposite to this side, that is 77 degrees. And that's going to give you the value for A square. Let's see what that is. 60 squared plus 34.5 squared minus 2 into 60 into 34.5 into cos of 77. Okay, so this is giving me 3858.95. And then when we take square root of this, that turns out to be 62.12. Okay, 62.12. That means the distance from S to B, that is 63.12. So which distance is closer? Which distance is smaller? You can see that the distance earlier was 60 and now it is 62.12. What did they ask? They asked us whether the ship is now closer to B than it was when it left A. Well, no. No. It was closer to B in the beginning. The ship was closer to B at the point A. Now it's not as close, right? Why? Because we know the distance is now 62.12. Earlier it was 60, so it was closer earlier. All right, let's move on. Now the next one says, question number 25 from this paper. Two congruent parallelograms, that means they're exactly the same. Their lengths, their angles, their all the sides are all equal. They're joined like this. The vector QP is A, the vector PV is B. And we're given that X is the midpoint of VT. Okay, this is the midpoint of VT. VW ratio WR, that is 1:2. This is 1:2. Okay, no, the other way around, I'm sorry. This is 1:2. So if the total length was 3 units, it's broken down like this, 1:2. Prove that Q, W, and X lie on a straight line. Q, W, X, we need to prove that this is a straight line. How do you prove that this is a straight line? We're talking about vectors here. What we can do is we can find the vector QW and WX. And if we can prove that they're both parallel, since W is a common point, we can say that these 3 points are collinear. So we can say that they have the same direction basically. If QW and WX, if they have the same direction, that means they're lying on a single straight line. Okay, so we need any two of these vectors basically, QW, WX, or QX. You can find any two of these vectors. If they have the same direction, that means these 3 points are collinear, they lie on a straight line. Now, how do we find these vectors? Let's see how we can find QW first of all. Now, we can look at the diagram and see how we can go from Q to W. We can go from Q to R, and then we can go from R to W. This is one way to get to W from Q, right? So QW vector is QR, which is B, plus RW. What is RW? This whole vector is A. RW is 2 out of 3 units, right? If the total length was 3, RW is just 2 out of that, right? So we can say RW vector is basically 2 over 3 times A. Okay, so QW vector turns out to be this. Now, what about the vector WX? Can we find that as well? How do you go from W to X? You can go in this direction and then in this direction. Q to V. What's QV? Well, it's 1 unit out of 3. In which direction? In A direction. So that will be 1 over 3 times A plus V to X. Well, this complete vector is B, right? Because these are congruent parallelograms. This vector is also B. X is the midpoint of VT. So what's the vector Vx? This part? That is half B. Right? This is half B and this is 1 over 3 times A. This is the vector WV. WX, sorry. Okay, this is the vector WX. If we've got WX and QW, how do we show that they're parallel? One way to do this is that we divide their corresponding components. If the corresponding components have the same ratio, we can say that they're parallel. Let's see if we can do something like that. This is, yeah, so let me actually rearrange it first because otherwise we can end up using this wrong ratios. 2 over 3 times A plus B, that is QW, and WX is 1 over 3 times A plus 1 over 2 times B. Okay, now can we write one of these vectors as a multiple, can we write one of these vectors as a multiple of the other vector? Well, if you think about it, if I were to multiply wx by 2, I could get this first vector, right? Qw can be written like this. If I take 2 common from this, for instance, it can be written as 1 over 3a plus 1 over 2b inside. And that's exactly what wx is. So we could say qw vector is 2 times wx vector. That means they have the same direction. Since we can write one vector as a multiple of the other vector, that means they are parallel vectors. Now, since these are parallel vectors, they have the same direction. That means Q, W, and X, they all lie on a straight line. Okay, let's move on. First, number 26 from this paper, that's the last one that we want to do from this particular paper. So this person ran an 800-meter race in 140 seconds. The speed time graph represents the first 100 seconds of her run. She ran the last 40 seconds with constant deceleration. Work out her speed as she finished the race. Okay, now this is a speed time graph, right? It's a speed time graph, and she's running an 800-meter race. Okay. We have the first 100 seconds of her run, and she is completing 800 meters in 140 seconds in total. Okay, so we have an incomplete graph here. We have to complete it, and we have to basically figure out what was her speed as she finished the race. And they're telling us she ran the last 40 seconds with constant deceleration. Now, it's a speed time graph. The gradient of a speed time graph is going to give you acceleration or deceleration, right? If the deceleration is constant, that means the gradient of this graph is going to be constant. That means it's going to be a straight line. It's going to be a straight line in this last part of the journey. Now, the straight line might look like this, it might look like this, might look like this. We don't know. We have to figure out what the final speed is. Now, let's assume a random point here. We don't know what the actual point is going to be. Let's say the point is somewhere here. Okay, I'm just choosing something randomly here. And the question is, what's the speed at this point? Let's call this V. The speed at this point. This is what we're looking for. What we know is that the distance traveled in these 40 seconds is 800 meters. Now, in a speed time graph, the area under the graph represents distance traveled. So if we can somehow find the area under the graph, the total area under the graph, and equate that to 800, we can find the value of V from that. Okay. Now, how can we do that? Let's break this area down into different parts. Let's say this is one part, this whole trapezium, right? Because this is something that we already know about. Can we find the area of this trapezium? Let's find this first of all of this region. Area of trapezium is given by half into sum of parallel sides into height. What are the parallel sides? One side is 100 and another side is 10 to 100, that's 90. So it's half into 100 plus 90 multiplied by the height of this trapezium, that is 6. Okay. Plus the area of this region. This is also a trapezium. In this case, the parallel sides are vertical. This side, this green side, and this green side, they are parallel. Okay. What are the lengths of these sides? This side is 6 units, so that's half into 6. What about this side? Well, this is V, that's what we are looking for. Into height is the distance between the parallel sides. For 100 to 140, this distance is 40 units. This total area has to equal 800, and that is going to give us the value of V. Let's simplify this now. 6 and 2, they get cancelled. We have 3 into 190, and that's giving me 570 plus 2 and 40 get cancelled. We've got 20 here. 20 into 6, that is 120 plus 20V equals 800. 20V equals 800 minus 120 minus 570, that is 110. And the value of V turns out to be 5.5. That's the speed at which she ends her journey. So this V is actually supposed to be here, 5.5. All right? And that's what we were looking for. This is the speed. This is the speed at which she ends the race. She finishes the race. Okay, let's move on to the next paper now. June 2022. Let's have a look at a few questions from this paper as well. First of all, we're starting with question number 12 from this paper. It says 4y equals 4x. Which statement is correct? Take one of these boxes. Okay, 4y equals 5x. It says y is 80% of x, y is 25% of x, x is 20% of y. Okay, so if you look at it this way first, if we make y the subject, that gives us y equals 5 over 4 times x. Okay, and that is y equals 1.25x. 1.25. That's the same thing as 125%, right? Percent means per 100. So 1.25 is the same thing as saying 125 over 100, 125%. So that means y is 125% of x. Well, we've got one choice here that says that y is 125% of x. So that's what it is supposed to be. We can write it like this if we want. Y is 125% of x. Okay, but we can also verify that the other choices are not correct. If we were to make x the subject, that will give us 4 over 5 times y. That's 0.8y. In percentage terms, that will give us something like this, that x is 80% of y. Well, we don't have any of those choices here, so that's not correct. This is the final answer. Y is 125% of x. Okay, question number 15 from this paper. Now, this is a relatively unusual question. It's like solving a puzzle, it seems. In the grid, the product of each row, column, and diagonal is 1. Okay, so each row, each column, and diagonal, the product of those numbers is 1. We need to complete this grid. Okay, so we have the most amount of information in this column and in this row. Let's complete these first. So in this row, the product has to be 1, right? So 1 over 4 into 4, that is already 1. So we should have 1 here so that the product remains 1. What about this row? 4 into 1 over 8. You can do that on your calculator. That will be 1 over 2. We need to make this product 1. 1 over 2 into 2 is going to give us 1. So we have 2 here because of that. Right, now you can see 2 into 4 into 1 over 8. That's 1, right? Okay, what can we do next now? Now we've got this diagonal. We know two things on this diagonal already. 2 into 1, that's 2. What should we have here so that the product is 1? 2 into 1 over 2 is going to give us the product 1. Okay, so this should be 1 over 2 then. All right, now what about this row, for instance? 1 over 4 into 1 over 2, that is 1 over 8. So what should we have here to make the product 1? 1 over 8 is the rest of it. So if we have 8 here, 8 into 1 over 8, that's going to give us 1. Okay, and then we can fill out the remaining two boxes as well. 8 into 2 is 16. So we need 1 over 16 here so that the product becomes 1. And then 1 over 16 into 1 into 16 is going to give us the product equal to 1. So we have 16 here. And now all of those conditions are satisfied. Every single row in this grid, every single column, and every single diagonal the product is 1. Okay. All right, let's move on to the next one. Verse number 16 from this paper. So Amal received 6,660 pounds from selling the 3,000 sandwiches in June. Okay. The numbers of sandwiches sold were in this ratio: meat, cheese, vegan, 9:4:7. The price of a meat sandwich is 2.39. The price of a cheese sandwich is 1.89. We need to work out the price of a vegan sandwich. Okay, so how do we think about this? We know the total number of sandwiches and we know that the ratio of the number of sandwiches is this. Can we work out the number of each type of sandwich that we've got? So we have 3 types of sandwiches: meat, cheese, and vegan. Okay. How many meat sandwiches do we have? 9 over what's the ratio? Yeah, so 9 plus 4, that is 13. 13 plus 7 is 20, right? So 9 over 20 multiplied by 3,000. Do we really want the rest of them? Yeah, we actually do need them. 4 over 20 into 3,000, and then 7 over 20 into 3,000. Now from this we can work out the number of sandwiches of each type. Okay, let me just calculate these. 9 over 20 into 3,000, that's giving me 1350. And then 4 over 20 into 3,000, that's 600. And then the remaining 1,050 are vegan sandwiches. All right, now the total amount that she received by selling these sandwiches was 6,660 pounds. And the price of meat and cheese sandwiches is given. Can we figure out the total amount that she received from meat and cheese sandwiches now? We can, because we know the total number of meat sandwiches, that is 1,350. If we multiply that by 2.39, that's going to give us the total amount she received from the meat sandwiches. Let's figure this out. 1350 into 2.39, that's giving me 3226.5. Okay, and then from the cheese sandwiches, each cheese sandwich is worth 1.89 pounds. So what about 600 cheese sandwiches? 600 into 1.89, and that's giving me 1134. Okay, now let's add them together. Or in fact, from 6,660, what we can do is we can subtract these two numbers. Okay, so let me just calculate that here. 6,660 minus 3226.5 and 1134. Let's see what this turns out to be. Because this will be the total amount that you received from selling vegan sandwiches. Okay, so 6,660 minus 3226.5 minus 1134, and that is giving me 2299.5 here. So what should we have here as the price of a single sandwich? This was the number of sandwiches, and this was the price of the sandwiches. So what price do we need to have here so that the total amount that she gets is 2,299.5. Let's call this X. We can say X equals 2299.5 divided by 1,050. And that should be the price of one vegan sandwich. Let's see what this turns out to be. That's giving me 2.19 pounds. That should be the price of one vegan sandwich. Okay, let's move on. This was question number 16, part B. Okay. Now it says a company makes and sells boxes of washing powder. Let's actually write that number down here. This is 2.19. A company makes and sells boxes of washing powder. The company wants to increase the amount of money it receives per kg of powder. Just give me a second. I'm just connect my earbuds again. Okay. A company makes and sells boxes of washing powder. The company wants to increase the amount of money it receives per kg of powder. To get the required increase, it can increase the price to 5.88 pounds or reduce the mass of powder in the box by X%. Work out the value of X to 2 decimal places. Okay. Now, she can do one of these two things, right? She can either increase the price to 5.88 pounds. She wants to increase the total amount that she's receiving per kg. Okay. Now, what's the per kg amount that she's receiving initially? Initial per kg amount. Let's write that down first. Let's see what that is. That's 5.60 divided by 1.68. Right? 5.60 is for 1.68 kilograms. So what about 1 kg? 5.6 divided by 1.68. And that gives me 10 over 3 or 3.333. Okay, you should not round it off yet. Let me actually just write it like this. 10 over 3. Okay, that's the initial per kg amount. What's the final per kg amount? After the increase. Let's see what that is. After the increase, the final amount would be 5.88 over 1.68. What's that going to give us? 5.88 divided by 1.68, and that's 7 over 2 or 3.5. So the difference between these two values is going to give us the increase per kg. Okay? Increase amount per kg. What's that? That is the difference between them. 3.5 minus 10 over 3. That is giving me 1 over 6. Okay, or 0.16666. Yes, 0.16666. That's the increased amount per kg. Now, this is one way to get this increase in amount. Another way to get the same increase would be that you somehow reduce the amount in the box by X% so that it gives you the same increased amount per kg. Okay. Now, let's say we want the final per kg amount to be 3.5, right? How much mass should we have of the washing powder in that case if we want the per kg amount to be 3.5 pounds? Let's figure that out. Let's say the total mass that we want inside here is M. Okay. Then M over, or in fact the other way around, 5.6 pounds. In fact, we don't know that yet. Just think about it again. What we want is, yeah, so the price has to be the same. Okay, so if keeping the price the same, what mass would we have so that we get the same final per kg amount, that is 3.5. Okay. Let's figure out the mass that we get from that. That's going to be 5.6 over 3.5. And that's 19.6. 19.6. I'm sorry, this is, I've done something wrong there. Divided by 3.5, that's actually 1.6, not 19.6. It should be 1.6 kilograms. So if we have 1.6 kg here, instead of 1.68 kg, we would get the same amount per kg. Okay? Now, we could actually just get rid of this working. I just realized it was kind of not needed. Just focus on this now. We have the final per kg amount. We have the per kg amount after the increase. That's 3.5. We want the same per kg amount by reducing the mass of powder somehow. So what mass do we need to get the same per kg amount? We would want it to be 1.6 kilograms. Okay, so by what percentage will the mass need to be reduced then? Percentage reduction in the mass of water, in the mass of powder. What should that be? How much do we want to reduce it by? 1.68 minus 1.6. This is the difference that we want. What was the initial amount? The initial amount was 1.68. So we have to calculate it as a percentage of that. Or you can actually do it the other way around. It will turn out to be negative, but we can make it positive then. Let's see what this percentage turns out to be. So that's 0.08 divided by 1.68, and that is giving me minus 0.0476%. Okay, this is the percentage change in mass, right? That's why it's turning out to be negative, because we're reducing something. Now, what's the percentage reduction then? Reduction already incorporates this negative sign. So we can say the percentage reduction therefore is 0.05%, because we want our final answer to be correct to two decimal places. We can say that's just 0.05%. That's the percentage reduction that we would need there. Okay, I hope that makes sense. Let's move on to the next one now. Question number 28 from this paper. So this was question number 20. Now let's do the last one from this paper. That is question number 28. It says AB, BC, and CD are sides of a regular 12-sided polygon. Now, what's a regular polygon? A regular polygon is a polygon that has all sides equal and all angles equal. Okay? All sides equal and all angles equal. Okay, I'm sorry about that. So you're right about that. So I did not multiply that by 100. Yeah, so let me just check that again. Yeah, so I forgot to multiply that by 100. Let me just correct that. That should have been 4.676 rather than this. Let me just change that. This was 4.76. So when make it positive, that becomes 4.76% to two decimal places. Yeah, thank you. 4.76%. That should be the final answer that we get here to two decimal places. Okay, all right, let's move on now. So we have this regular 12-sided polygon. CDMN is a square. Prove that points A, B, and N lie on a straight line. Now, how can we do that? How can we prove that A, B, and N lie on a straight line? It's not drawn accurately, so it's not in a straight line on this diagram. But how can we prove that? If we can somehow prove that this angle at the point B is 180, then it has to be a straight line, right? Because the angle in a straight line is 180 degrees. Now, how do we prove that? Since it's a 12-sided regular polygon, can we figure out uh, one of these angles? We know that the square has all angles 90. For a 12-sided polygon, we can say n is 12, right? What's the sum of all angles? N minus 2 into 180, right? In this case, the value of n is 12. So we can say 12 minus 2 into 180. That's going to be the sum of all the interior angles of this polygon. Then what about one angle? For that, we can just divide this by n. So divide this by 12. This is going to be one of these angles of the polygon. Okay, let's see what this turns out to be. That's 1800 over 12. And that is giving me 150 degrees. Okay, this is 150 degrees. So this angle is 150 degrees. So all of these angles, all of these interior angles of the polygon, they are 150 degrees. All right. So this is 150. Now, if this is 150, if we make a straight line here like this, or let me actually just connect B and N first. If I connect B and N, then what do I know about this triangle? I know that this is 90. I know that this is 150. Can I work out this remaining angle? Right? The total angle in this on this circle is 360. So if this is 90 and this is 150, 360 minus 90, that's 270. 270 minus 150, that's 120. This angle here should be 120. So we can say the angle BCN is 120. Now, if this angle is 120, you see, this 12-sided polygon is a regular polygon. That means all sides of that polygon are equal. That means this side is the same as this side. And since this is also the side of a side of the square, this is also the same. So this is an isosceles triangle with two sides equal. That means the remaining angles therefore are 30 each. So this is 30 and this is also 30. So that means the angle CBN is also 30. And that means the angle ABN is 180. 150 plus 30, that is 180. That means it's a straight line. ABN is a straight line. And that is what we had to prove here, that it's a straight line. Okay, let's move on. Okay, let's look at the next paper now, November 2021. Let's try this. It says a ball contains 5,000 centimeter cube of air. More air is pumped into the ball at a rate of 160 centimeter cube per second. The ball is full of air when it becomes a sphere with radius 15 centimeters. We've got the volume of the sphere given. Does it take less than 1 minute to fill the ball? You must show your working. Okay, so we have 5,000 centimeter cube of air inside this sphere. That's already there. When the ball is full, it becomes a sphere with radius 15. Okay, let's actually find the volume of that complete sphere first of all. Let's see what that turns out to be. When it's full, it's 4 over 3 into pi into 15 cube. Let's see what this is. 4 over 3 into pi into 15 cube. And that is giving me 4,500 pi. Let me just keep it like this for now and not round off. That's the total volume of the sphere. Now, does it take less than 1 minute to fill the ball or more than 1 minute? How can you figure that out? Let's see what happens in 1 minute. So it's 60 centimeter cube per second. What about 1 minute? In 1 minute, it should be 160 into 60 seconds, 9600 centimeter cube. This much should be pumped into the ball in 1 minute, 160 centimeter cube, right? Now let's figure out what the total air inside the ball is after 1 minute. Total air inside the ball after 1 minute. What's that? That's 5,000 that was already there before, and 9,600 that we have added more. This is giving me 14,600. Okay. This is the amount of air that is there after a minute. All right. Now, this is the amount of air that is there after a minute. Is the ball full at this point? Well, let's actually simplify this as well. 4,500 pi and see what that turns out to be. 4,500 pi, and that is giving me 14137. So this is 14137 centimeter cube. Okay. So if we keep pumping, we would expect there to be 14,600 centimeter cube of air pumped up to that point, but the total capacity is this. That means it does take less than a minute to fill the ball, because in 1 minute, we would have filled more air than the capacity, which is not possible. Of course, that means before 1 minute, the ball is basically full of air. So yes, we say it takes less than a minute. Right? This working is important, of course. We say it takes less than 1 minute to fill the ball. All right, let's move on. Question number 16 from this paper. It says, here's a cube with edge length x centimeters. One diagonal is shown. Circle the length in centimeters of the diagonal. All right, now it's a cube and the length of one of these edges is x centimeters. How can we find the length of this diagonal? Let's think about this. We have this length x as well, and that's not the same triangle. We'll have to use two triangles apparently here. If we use that one, yeah, so we can actually use this triangle. You can say let's use this triangle here. To find the length of this diagonal. All right, now this edge is going to be x. The problem is we don't know what the length of this edge is, this side is. Now this is x and this is also x. Let's call this something. Let's call this y. What is y going to be? It's a right angle triangle, right? Y square equals x square plus x square. Y square equals 2x squared. All right, it's a right angle triangle. And now we make use of this right angle triangle. The other one that I've drawn there, this one. This is also a right angle triangle, right, with a right angle here. Now, let's call this D, the diagonal. D square equals x square plus y square. And y square is 2x square. So we have x square plus 2x square. And d square equals 3x square. D equals under root 3 times x. And that's your final answer. That's basically the first one. Okay. This is the actual answer. Okay, part B now. It says the total length in centimeters of the edges of the cube is a multiple of 18. The total length in centimeters of the edges. How many edges do we have in a cube? 12 edges in total. So the total length should be 12 times x. They're saying 12x should equal 18. So, or sorry, a multiple of 18. It's not exactly 18. It's some multiple of 18. You can say 18 times n. Okay, some multiple of 18. Now, does that mean x is a whole number? Well, we can't say for sure, because if the sum was 18, for instance, x would turn out to be 18 over 12, that's 1.5. But a multiple of 18 could also be 36. In that case, we would say 36 over 12, and that's a whole number, that's 3. So it might not be a whole number, it might be a whole number, we can't say for sure. Now, what are the options? X is a whole number, x is not a whole number, x might be a whole number. So x might be a whole number, we can't say for sure. Okay? All right, question number 17. 20 people were asked which device they used more often, laptop or phone. The table shows the results. One male and one female are chosen at random. Work out the probability that exactly one of them said laptop. Okay. One male, exactly one of them should say a laptop. Now, what are the possibilities? One possibility could be that both of them say laptop, both of them say phone, and then one of them says laptop and the other says phone. Now, in this case, there are two possibilities, basically. You can say the male chosen says laptop, and the female chosen says not laptop, she says phone, right? So ML means male laptop, FP means female phone. Like, this is one possibility. If male says laptop, one male and one female are chosen. Yeah, so what's the total number of males? You can write that on the side here. 11. What's the total number of females? That's 9. Okay, out of 11 males, what's the probability that he says laptop? That's 2 over 11. And that means we multiply them. The female says phone. Out of 9, probability of her saying phone, that's 5 over 9. This is one possibility. Another possibility could be that the male says phone and the female says laptop. What's the probability of the male saying phone? That's 9 over 11. And the female saying laptop, that is 4 over 9. So we have to consider two possibilities. Either the male says laptop or the female says laptop. You can also draw a tree diagram for this if you want to make this simpler. So these are two possibilities. There's an or between these two cases that means we have to add them up. It's either this case or this case. So we add them up together. Okay, let's see what this turns out to be. 2 over 11 into 5 over 9. That's 10 out of 99. Add to this 36 over 99. Okay, that means that basically gives you 46 over 99 as the final result. So you write here 46 over 99. Now it says 2 males are chosen at random. Work out the probability that they both said phone. Okay, now 2 males are chosen. So out of these 11 people, 2 people are chosen. What's the probability that both of them said phone? What's the probability of the first one saying phone? 9 out of 11. But be careful here. Once you've already chosen a male, now you have one less male left. So the second time you choose a male, you have only 10 people to choose from. So in the second time, the denominator is just 10 now. And you have already chosen one person who said phone. So what's the number of people saying phone left? 8. So that's 8 out of 10. That's going to give you this probability that both of those males said phone. You can see what this turns out to be. This is giving me 36 over 55. Okay, and that's the result that we get from this. Okay, let's move on. Question number 18. It says on the grid, identify the region represented by these three inequalities. Label the region R. Okay, so first of all, treat them as equations and draw those inequalities. X equals 5. That's a vertical line at 5. So you would draw it like this. Let's say there's a vertical line here. It should have been at 5. Let me just correct that. Yeah. There's a vertical line here at 5. And then y less than or equal to 4. Draw this line, y equals 4. That will be a horizontal line. This is y equals 4 line. This is x equals 5 line. X plus y equals 6. Okay, how do you draw this line? Take any 2 points, put x equals 1 for instance, y will be 5, x equals 1, y equals 5, that will be here. Put another value of x and y, put x equals 3, y equals 3, x equals 5, y equals 1. This is the line that we are getting from this. This is going to look like this. It's a straight line like this. Okay, and now you need to think of which region you're going to shade here. X less than or equal to 5. What does that mean? You have to be to the left of this line. Okay, that's one condition. Y less than or equal to 4. You have to be below this line. You have to be below this line. Okay, and what about the green line? You first should make y the subject. When you make y the subject, that gives you y greater than 6 minus x. It's a greater than sign. You have to be above this line. So above this line. And since there's no equality sign here, it's a strict inequality, you should make it dotted or dashed so that it's clear that the region on the line, the points on the line are not included. So you have to be above this line. Which region satisfies all of these conditions? It's this triangle in the middle. And that is what you're going to shade here. This is your final result. All right, let's move on. That was question number 18 from this paper. Yeah, that's it. That completes this paper as well. Now, the last one that we want to do is November 2020. Let's have a look at this now. Okay, let's try this now. It says at a party there are 90 people, 48 are women and 42 are men. Some women leave, some men arrive. Okay, so there are 90 people in total, 48 are women and 42 are men. Some of the women are leaving, some of the men are arriving. The ratio of women to men is now 10 to 11. Are there now more than 90 people at the party? Show you're working to support your answer. Okay, so the women are leaving and the men are arriving. So that means the number of men has to be greater than 42. So men have to be more than 42. And the number of women has to be less than 48. Okay, now that's given. Now the ratio is 10:11. Women to men ratio, women to men ratio, that is given to be 10 to 11. Okay, now how do we think about this? We don't know how many women are leaving and how many men are arriving. So we don't know if the number is less or greater as such for now. But let's think about what are the possibilities. 10 to 11. Let's make it somewhere closer to 90. So the total number right now is 21. Can we take it closer to 90 somehow? 28 into 4, that is 84. So if the total number was 84, what would this be? 40 and 44. Okay, and if the total number was more than 84, 21 into 5, that will be 105. If it was 1 or 5, the ratio would be 50 and 55. Okay, let's see which one of them is possible. Can the number of women be 50? No, it has to be less than 48. Okay, so this is not possible. Can it be 40? Yes. The number of men greater than 42? Yes. And if we just consider, just to be sure, we could consider another case as well. We could consider 30 and 33 here as well. And that's clearly not possible because here the number of men. So the number of men has to be greater than 42. So it can't be 33. This is also not possible. This is the only possibility that we have then, that the number of women, because only in this case, both of these conditions are going to satisfy, right? If we take any other combination of any other total number, the number of men and women that we get are not going to be integers, right? The only integer possibilities that we get close to 90 are these. And it's clear that since the number of men has to be greater than 42, this one is not possible. The number of women has to be less than 48. This is not possible. 40 and 44, this satisfies both the conditions. The number of women is less than 48, number of men is greater than 42. So the total number has to be 84. So are there now more than 90 people at the party? No, there are less than 90 people at the party now. Okay, let's move on. Question number 20 from this paper. A, B, B, C, C, D, and D, E are four sides of a regular decagon. Regular decagon. Decagon is a 10-sided figure. Regular means all the sides are equal, all the angles are equal. Work out the size of angle W. Okay, now how do we think about this? These are sides of a regular decagon. Can we find these angles somehow? Let's figure that out. N minus 2 or n minus 2 into 180. That's the sum of all angles in a polygon. But since it's a regular polygon, each angle is going to be this divided by n. So in this case, we can say 10 minus 2 into 180 divided by 10. This is going to be the size of every one of these angles. Let's see what this turns out to be. 18 into 180 into 8 divided by 10, and that's giving me 144. That means each of these angles is 144. This is 144, this is 144, and this is 144. And the remaining angles are equal. They're saying this is W, this is W. Now, this is a five-sided figure. We can look at this now. What's the sum of angles in a five-sided figure? In a four-sided figure is 360, and five-sided it's 360 plus 180, that's 540. Or we can calculate that again if we want. This total, the sum of all of these angles, what is this going to be? This is going to be W into 2, that's 2W, right? W plus W, that's 2W, plus 144 plus 144 plus 144, we can say that's 3 times 144. This is the sum of all angles in this figure. Now, this is a five-sided figure. What's the sum of angles in a five-sided figure? 5 minus 2, n minus 2 into 180. That's 3 into 180. And that's going to give us the value of W. We can say 2W plus 3 into 144. That's 432. That equals 540. And W equals 540 minus 432 divided by 2, that's 54. The value of W therefore should be 54 degrees. Okay, so this has to be 54 degrees. Okay, let's move on. Question number 27 from this paper. It says these 20 discs are in a bag. Okay, which 20 discs? Okay, so these 20 discs that you see here, these are in a bag. 2 of the discs are taken at random from the bag. Work out the probability that the first disk has a smaller number than the second disk. Okay, so we're taking out 2 disks. We need the probability that the first one has a smaller number than the second one. Now, let's actually count them. There are 20 in total. So these are 4 and these are 6. these are 7, and these are 3. So we know the probabilities for each one of them right now. Now the first one has to have a smaller number than the second one. Okay, so what are the possible cases then? So because there are 4 different types of this, we'll have to consider a number of different cases for this actually. You can think of a tree diagram if you want, 4 into 4, that will be 16 branches, too much broad. You can just think of it logically. If the first number has to be smaller, one thing is clear, that it can't be 44, right? Because then 44 cannot be smaller than anything. The first number has to be either 11 or 22 or 33. These are the 3 possibilities for the first number. Let's consider these 3 possibilities. We'll have to consider all of them separately. So one possible case would be that the first one is 33 and the second one is, sorry, first is 11. Let's actually start like that. First is 11. Then what about the second one? The second is greater than 11, right? So that means all of these possibilities. What would this be? What's the probability of getting uh, a disk that has 11 written in it? It'll be 4 out of 20. Now, once one of these disks is taken out, what's the number of disks that is left inside? That's 19. Out of those 19, since you want it to be greater than 11, that means all of these, it could be any of these cases, 22, 33, or 44. What's the total number here? It's 16. 16 out of 19. This is one possible case. You can see what this turns out to be. And another possibility would be that the first one is not 11, but it's 22. If the first one is 22, then the second one can be greater than 22. What's the probability of the first one being 22? 6 over 20. And the second being greater than 22, that's these two cases. That's 10 out of how many? 19 remaining cases. And then similarly, you can consider the last case. The first one is a 33, and then the second one is a 44, right? Because greater than 33 is just 44. Okay, now what's the probability of the first one being 33? 7 out of 20. And the second one being greater than 33, that means it's a 44. That's 3 out of 19. Let's calculate each of these numbers and see what they turn out to be. 4 out of 20 into 16 out of 19. That is giving me 16 out of 95. And the second one is 3 out of 19. And then the last one is 21 out of 380. Now it could be any one of these 3 cases. So what we do is we add them up. We say it's either the first one or the second one or the third one. We add those cases, and that gives us the final probability. And that is giving me 29 out of 76. And that's the final result that we get from this. 29 over 76. Okay, let's have a look at the next one, possibly the last one from this paper. Okay, so it says a horse runs in a field. The speed time graph represents the first 12 seconds of the run. After how many seconds had the horse run a distance of 75 meters? So we've got information about the 12 seconds, about the first 12 seconds of the journey. Now, after how many had the horse run a distance of 75 meters? How do you figure that out? It's a speed time graph. The area under the graph represents distance traveled, right? Now, we already know the distance up to this point, as in we can easily find the distance up to this point, right? It's a triangle. We can find this area. Let's see what that is going to be. half into base, which is 4. It's a right angle triangle, into height, which is 10. So in the first 4 seconds, sorry, 4 into 10. In the first 4 seconds, the horse has already traveled 20 meters, right? This is 2 into 10, that's 20 meters. Now, how much more does he need to get to 75? We don't know where that point is going to be, but let's just say it's somewhere here, let's say, right? After how many seconds? That's what you're looking for. If we call this point, we don't know where the actual point is. I'm just marking this randomly here. Let's say this is T, okay? Then what about the area of this rectangle? We know the height of this rectangle. The height of the rectangle is 10. So we can say 10 multiplied by the base. What's the base? This is T, this is 4. The base is going to be T minus 4, right? T minus 4. That's the base. So T minus 4 into 10. That's the area of this rectangle. Area of the triangle plus the rectangle, this should equal 75. And now we can just solve this and see what that gives us. 20 plus 10t minus 40 equals 75. 10t equals 75 plus 40 minus 20, and that's giving me 95. So the value of t that we're looking for, that turns out to be 9.5. So after 9.5 seconds, the horse has run 75 meters, and that is what we were looking for. This is the final result that we get from this. After 9.5 seconds, the horse has traveled 75 meters. Okay, and that's it. I hope you found this video helpful. If you found this video helpful, make sure that you subscribe to the channel. You'll find a lot of other helpful content here as well, especially for your A-level exams later on in 2 years. We'll find over the next 2 years, you'll find this channel extremely helpful. And make sure to press the like button and also share with your friends so that more people can benefit. I'll see you again in another video. Bye.